All right, so today we're going to continue on in Chapter 2, and this is our last section we're going to focus on in Chapter 2. What we're going to look at is logical reasoning and kind of some of the rules of logic. So first thing, as we mentioned before in the first section, deductive reasoning is when you take a series of facts, definitions, and accepted properties, and you form a logical argument from it to show that something must be true. One of the first laws of reasoning is law of detachment. Right? This comes into play with an if-then statement. So in an if-then statement, a lot of times we'll write that as P implies Q, which is really if P happens, then Q has to happen. All right, and what the law of detachment says is that if we know for sure that P happened, then we get the guaranteed result that Q happened. All right, so symbolically it looks a lot like this, where P implies Q. We know P, so therefore we get Q. So it might be something like, if it rains, then the softball game will be postponed. We find out it rains, then based on the if-then statement, we know that the softball game is postponed. All right, assuming it's a true statement. So that's one of our main laws that we use, law of detachment. The second main law is law of syllogism, and later we'll see this as something called transitive property, but this really links two arguments together. All right, so this one we have an if-then statement, P implies Q, and then we have another if-then statement that says if Q happens, that implies R. Now, what law of syllogism allows us to do is pull those two together and say, you know what, that means if P happens, I know for sure R is going to happen. All right, because P implies Q, so if P happens, Q has to happen. If Q has to happen, then R will have to happen because of that last conditional statement. All right, so these are two laws that we'll end up using in some of our arguments as we go through the year this year. All right, law of detachment and law of syllogism. They're actually pretty closely related. So an example here, if it rains, then PE will be indoors. So symbolically, we'll say R implies I. Rain implies indoors. The next one, if PE is indoors, then we will play badminton. So symbolically, we'll say I, indoors, and B, badminton, all right, as we go through. Now, it says, you know what, it's raining. All right, so because it's raining, we have, really, rain would force this first one, so R goes to I. So when it rains, we can say I happens for sure. But then we know I goes to B, so if I happened, we know we get B for sure. All right, so what we do a lot of times in the argument is we're actually going to use law of syllogism first, and we're going to take the two conditional statements, R implies I and I implies B, and we're going to push that together into one, where R implies B. All right, then we'll take law of detachment second, and we'll say, you know what, we know R happened, that means B has to happen. All right, so it's merging multiple conditional statements into one, so we have a little bit cleaner arguments. All right, so now we're just going to look at a couple reminders from the previous sections. So the first one is conditional statement and the contrapositive have the same truth value. All right, so remember conditional statement, if that's P implies Q, then the contrapositive, we flip the order and we negate. So not Q implies not P. All right, so both of those would have the same truth value. And also the converse and the inverse would have the same truth value as well. Because really the converse and the inverse, it has that same relationship that the original conditional statement and the contrapositive would have. Now, another thing to remember is that with biconditional statements, that really means that we have both directions of the argument. So if we have P biconditional Q, which is P happens if and only if Q happens, then we can say P implies Q, but also Q implies P. And what this is going to allow us to do is rewrite some of our conditional statements to help make arguments a little bit easier for us to work through. All right. The contrapositives is the one that we're going to probably use the most as we write things, and biconditionals, the second. All right. So we're going to take a look at a couple examples here, and really what we're going to do is we're going to very symbolically build an argument using if-then statements we know are true. All right, and the first thing we're going to do, all right, is we're going to go ahead and we're going to write the contrapositive for any of these if-then statements. And this way we just have both available. So for the second one here, the first one's a biconditional, so I'm going to leave that as is. The second one, I'm going to say not T implies not Q. All right, so contrapositive of that statement. The next one, we flip the order and negate, so not S would become S, implies not R. And then T goes to S, so that's not S, implies not T. All right, now that top one, really, if we wanted to, we could break it out into a few arguments, but we're going to leave it like that, and we're also just going to say, you know what, the not R implies biconditional, not P, because the contrapositive in either direction would also be true. All right, so now we want to build an argument. So when we build the argument, what we're going to look for is we're going to look for a fact that really only shows up once as we go through here. So I've got R in a couple spots. All right, so I've got an R here, and I've got an R here. All right, I've got S in a couple spots, there and there. I've got T in a couple spots, there and there. So I'm going to start my argument with the Q and try and work my way through the argument. All right, and usually I'll start on the left side and use the left side if there's more than one thing that only shows up once, like here we have the Q and the P. I'll start with the one that's on the left side. All right, so I'm going to clear these circles off, and we said we were going to start with the Q, so we know that Q implies T. All right, so the next thing I'm going to do is I'm going to look for an argument that goes from T. All right, so I know from this last one, T implies S. So T goes to S. All right. Then I look for one that takes me from S. So I have a not S involved in this one. All right. But I need an S, so I'm going to swing over here to the contrapositive, and I'm going to use that. So that says that S goes to not R. All right. So S goes to not R. And now at this point, I kind of keep track. I've used the Q goes to T. I've used this one. All right, I've used the T goes to S, this one. I've used this one. All right, so now I'm going to go up and use that last one. All right, which was R biconditional P. So if I look at that and I think about the contrapositive, that's not R implies not P. So I have not R implies not P. So if I pull this argument together, I like to think of it as like one string of thinking. So we're going to write that right in here. All right, and we have Q, we know goes to T. T we know goes to S. S we know goes to not R. And not R we know goes to not P. So if I summarize that into one conclusion, I can say Q implies not P. All right, and that's the first example. We're going to see other similar ones to that in here in just a second. All right, so taking a look at the example 2 here. First thing I'm going to do again is write the contrapositive. So I have not P, biconditional, not R. All right, I've got not V, biconditional, T, negating both sides. Now this one's more of a true contrapositive, so T implies S. And then that last one, R implies not S. All right, so I'm going to look through and look for something that shows up once. I've got two S's, I've got two T's, two R's, so I've got a V and a P. All right, so really doesn't matter. I'm going to go ahead and pick the P because it's here, showed up first. We could probably do it with the V as well, and we'll look at that afterwards. So let's see here. P, we know goes to R. All right, R, so I've used the first one. If I look for R, R goes to not S, based on the contrapositive of that last one. So we got R to not S. All right, not S goes to not T, from this one right here. All right, and then we go to that last one. It was a biconditional, so that would work either V implies not T or not T implies V. So we're going to go with not T implies V. And if we pull that all together, we have P implies V. And that would be our conclusion going through. All right, now just for the sake of argument up here, if we looked at that and started with V, we could say, hey, V goes to not T. All right, then we look for something that not T goes to. All right, so not T, and if I go with that, I roadblock. So I'm kind of stuck if I go in that direction. So if you ever pick one of the letters and start going, you might run into a situation where you're completely stuck. That's a warning sign to go ahead and try the other letter if it doesn't work. So in this case, that choice didn't yield us any progress. All right, and that's going to happen on occasion. There's really no good way to avoid it. Now, taking a look at the last example here. All right, this one starts out in words, so we're going to kind of codify it as we go. All right, so we have possums are marsupials. So we'll say P implies M. All right, for possum and marsupial. All right, even though possum does start with an O. All right, and animal is a marsupial if and only if it has a pouch. So M, if and only if, pouch. So let's go ahead and recode here, and we're going to call the possum the O, and then P for pouch. All right, and then my aunt has a pet kangaroo. All right, so let's just write that off to the side because that's kind of a weird one. And kangaroos have pouches. So we'll say kangaroo implies pouch. So now let's take that weird statement, which was my aunt has a pet kangaroo, and we'll codify that a little bit. So it's really kind of like if it's my aunt's pet, then it's a kangaroo. So we'll say A implies K, where A is aunt and K is kangaroo. So now if we start pulling this together, it looks like I've got one A down the left-hand side. I've also got an O up there. So if we start with O, O goes to M goes to P, but then I'm stuck. All right, so if I go the other direction, I've got A goes to K. So it's my aunt, she has a kangaroo. All right, a kangaroo has a pouch, so K goes to P. And then a pouch implies marsupial, so to M. All right, and we're stuck at that point. We can't really go any further with the argument. So in this one, the possum being a marsupial really doesn't come into play because it doesn't lead into our argument at all. So we're going to have A implies M, all right, and we can put that back in words. My aunt has a marsupial. All right, and really, again, we're just combining logical arguments together to form a more concise argument. So this one was like 3 different statements, and we merged that into one statement that took us straight from my aunt to the fact that she has a marsupial. All right, hope that helps. Homework is very similar to the note set. It's really just kind of look at building that pattern and kind of working your way through with if-then statements. A goes to B, B goes to C, C goes to D. We can go all the way back and say A goes to D. All right, we'll be taking questions on this in class tomorrow. Have a great night. Bye.